Okay, tangent, if y equals tangent of u equals v minus 1 over v. V is natural log of x. What is the value of dy dx at e? You have a lot of ways you can do this. You can do it more symbolically, or you could just plug everything in to begin with. What did you do? Plugged everything in to begin with. So if you did that, you have tangent of v minus 1 over v. V is natural log, so you have tangent of natural log of x minus 1 over natural log of x. And you can take the derivative that way. It is a chain rule with a quotient rule inside a chain rule. Now, the other option is to do it more symbolically, and I want to show you that. Y prime would be secant squared of u Everyone agree with that part? Times u prime. I'm going to rewrite u to be v minus v to the negative 1. Are y'all okay with that? U prime would be v prime minus, well, plus 1v to the negative 2 times v prime. Everyone agree with that? Am I finished taking derivatives? Yes. And what is v prime? 1 over x. So, do what? What is the derivative of natural log?
It'd be derivative of x.
Okay, so now you may prefer just plugging it in. Does it matter? No. Abby, at the end of the period, you have a. Okay, so I could find the natural log. V is the natural log, right? What's the natural log of E? 1. So V at E is 1. 1 to any power is 1. Everyone agree with that? Let me move this out of my way so I have room to write. So this is 1. V prime at E would be 1 over E. Okay, now I need the secant squared of u. Well, I know that u is v minus 1 over v. V is natural log of x. At E, natural log of x is 1. So I get 1 minus 1, which is 0. Does everyone agree with that? Secant squared of 0. What is secant of 0? I heard someone say it. 1. How do you know it's 1? Cosine of 0 is 1, and the reciprocal of 1 is 1. And what's 1 over e plus 1 over e?
2 over e.
2 over e?
Yeah.
So D is the correct answer. Or, option 2, which is the option most of you probably chose. You do the derivative here. Secant squared of natural log of x minus 1 over natural log of x times 1 over x. And did y'all do a quotient rule on this? So low d high, what's the derivative of 1? 0 minus high d low, which is 1 over x, divided by natural log of x squared. Correct? And then plug in e. Natural log of e is 1. Natural log of e is 1. So I still get secant squared is 0. I still get 1 over e plus 1 over e. Either way works. So 2 options. Work it symbolically, or we could work it by plugging in the information. I wanted to work number 2 to show you we didn't get to do an example yesterday. Remember I said there are rules for this on your calculus helper, right? Go find it. What is the rule for the derivative of sine inverse? U is u prime over the square root 1 minus u squared. Everyone agree? That is one you will eventually have to memorize. I'm not making you memorize it before this test, but it's one you'll eventually have to memorize.
Would that help us to memorize it? Will that be on the test?
If it's on the test, I'll give you the formula. For now. Now, later in your life, you will need to memorize it. So if you want to go ahead and memorize it now, you can. It's one of those things, to me, I kind of like waiting till close to the AP exam. Yes?
We need Natalie's up over the office really quick.
Okay.
Thank you.
You're welcome. To me, it's something that's nicer to memorize closer to the AP exam. Because we're so far away from the AP exam, it doesn't come up that often. There's a good chance you'll forget it before then anyway, so it's just one wait to make you memorize. But you're welcome to memorize it now. You need it right before the AP exam. What is u prime? 16x. So even though I'm not making you memorize it, you do need to know how to use it. So that would probably be written on multiple choice as 1 minus 64x to the 4th. Any questions on how to use that? It's a formula, we can follow it. We could do implicit differentiation, but we would rather not. Okay, let's look at number 3. The limit as x approaches 4. How am I going to do that?
Plug in a 4.
Try plugging in a 4. What do you get?
0.
What's that mean?
There's a hole.
There's a hole. What does that mean I need to do?
Another
Factor.
Factor.
Equals 8.
Okay. Today we're going to learn a shortcut to limits.
That's already pretty short.
It is. Let's see that.
What about...
All right. It should kick off pretty quick. I know there are 2 temperatures in these rooms. There's hot and cold. There's no in between. Do what? No, it's set on like 70, and it'll be while the air's blowing, it's cold. While the air's off, it's hot. It's just. All right. Write this down. You will learn this again. You will revisit this in BC calculus a little more thoroughly. In AB calculus, it's barely in the curriculum, and it's actually not this year, but next year it is. It's kind of strange. But I've always taught it in AB calculus because it's a nice shortcut to know. However, next year in BC calculus, you will look at L'Hopital's rule in more depth and visit it a little more. For now, we're just going to use it in its basic form, and that's to make limits easier on you. So the limit is x approaches a of f of x over g of x. If that is a 0 over 0 limit, and if you want to know why this works, I'm not going to show you the proof, but it is on page 448 in your textbook. The proof only works if you have a 0 over 0 limit or an infinity over infinity limit. However, that's good news, isn't it?
Yeah.
Because those are the only hard ones. If it's a number, you're done. If it's a number over 0, it doesn't exist, you're done. So this works for the cases that are difficult. If you have a 0 over 0 or infinity over infinity limit, then the limit as x approaches a of the top over the bottom is equal to the limit as x approaches a of the derivative of the top over the derivative of the bottom. No quotient rule, nothing like that. Just taking the derivative of the top and the bottom. We're not taking the derivative of the entire function, not a quotient rule. It's just a shortcut. It's a trick, sort of, except it's a real theorem, and it's called L'Hopital's rule. So, how that applies. We are learning a shortcut to limits. Why did we not learn this in the limits chapter? Didn't know how to do derivatives. We couldn't do it in the limits chapter.
Derivatives first.
You can't do derivatives first because they involve limits. So we gotta learn it here. Wow.
How do derivatives roast?
What's the definition of derivative? Definition of derivative on your gateway exam. Limit is x approaches 0. That's x plus h minus f of x all over h.
Oh, that. That's for the measure.
A derivative is a limit of a slope. So, I gotta kind of understand limits before you can talk about derivatives. I mean, we could learn the shortcut to derivatives. As an 8th grader, we wouldn't understand what we're doing. Alright. Step 1. What do we do?
Plug it in.
Plug into. Why do I need to plug into first?
See if it works.
See if it's 0 over 0. If not, I am done, right? The end, I stop.
It's 0 over 0.
Okay, if I plug it in, I get 2 squared, which is 4. 4 times 3 is 12. 12 minus 14 is negative 2. Negative 2 plus 2 is, in fact, 0 over 0. So I know that I could factor the top and bottom, cancel, and this will be when it works. Are there a few of you where this is a little tougher for you to factor?
Yes.
You've got the 3 in front, right? You have to do Korean, y'all learn Korean method. Now, I am not saying that you don't need to know how to factor. You really do need to know how to factor. But we could use L'Hopital's rule. I could take the derivative of the top. What would I get? And the derivative of the bottom. And now plug into. And it is another way to do limits.
That is so... Yeah, you really missed the big part.
You'll be fine.
It's pretty easy.
You'll be fine.
I'm going to take it out,
Yeah, five minutes behind. You'll be all right. All right, let's look at the next one. What should I do first?
Plug it in.
Plug in the 3.
0 over 0.
Negative 3, actually. I do get 0 over 0. Remember, if I do not get 0 over 0, L'Hopital's rule will not work. It will give you wrong answers. It only works if you get 0 over 0 or infinity over infinity. So you have to have that before you start, which, again, is good news because those are the hard ones anyway. So I get the limit. If I were doing this limits way, how would I have to do it? Normal limits way.
Conjugate.
Multiplied by the conjugate. It's not impossible, not that hard, but it's kind of yucky. However, is the derivative on this a little yucky too? Yeah, so it doesn't make a problem completely... it's just different. What's the derivative of the top?
1.
The derivative of the bottom is 1/2, leave the inside alone, to the negative 1/2 times 2x. Now you can plug in negative 3. Negative 3 squared is 9. 9 minus 5 is 4. What is 4 to the negative 1/2 power?
1/2.
1/2. There you
How do you do
go.
that?
Square root,
Square root. Okay, got it.
and then flipped. So square root of 4 is 2, and then the negative flips it. Mm-hmm. So 1/2 times 1/2 is a fourth, times 2 is a half, times negative 3.
So I never have to worry about doing limits.
Pretty much.
I mean, this still is a limit, but...
Yeah, but
Okay,
you just make my life.
Okay. 1/2 times negative 3. Negative 3 over 2? Is that right? Yes?
We could do 2 over 3 negative.
Say that again. The derivative of the inside. Chain rule. Work on that mastery. Yes, ma'am.
What about the negative 2 on the bottom?
Oh, what's the derivative of it?
Okay.
Okay, everyone quiet. 1 and 2 you could do without L'Hopital's rule. L'Hopital's rule is not necessary. However, the next one, do you agree you get 0 over 0?
Probably. I have no idea.
So what's e to the 0 power? 1 minus 1 is 0, and there's a plus, so 0. The bottom, anything to the 0 power is?
1.
1 minus 1 is
0.
0. You have no way to do this limit by hand without L'Hopital's rule.
Not
You
even
can't.
like super advanced stuff.
No. In fact, this limit would not be on an AB calculus exam that was non-calculator, because they would know you couldn't do it. So, L'Hopital's rule doesn't just make limits easier long term.
Some possible.
It makes some that were impossible by hand possible. Because I can take the derivative of that, and I get the limit as x approaches 0 of e to the x plus 1. Everyone good with how I got e to the x plus 1? The derivative of the bottom, the 1 is 0. I get negative e to the negative x times negative 1,
So negative
or
e.
positive e to the negative x. Anything to the 0 power is 1. 1 plus 1 is 2. So that limit would not be on an AB exam.
Teachers and students, can I have your attention, please? The Spanish Club cooking class that was scheduled for this Sunday has been postponed until further notice. If you were going to attend the Spanish Club cooking classes this weekend, they have been postponed until further notice. Thank you.
Okay. So I want to reiterate, we have not only made limits that we already could do easier, we have taken some that we couldn't do and now we can. These are on the BC exam. L'Hopital's is a BC calculus tested topic. Again, you will revisit L'Hopital's rule next year and learn some more tricks and more in depth, but it just was worth learning at this point, right? Since we know derivatives, it's pretty easy to apply. Okay, let's look at the next one. What do you do first? Plug in negative 2. Left-hand side of the room, plug it into the top. Right-hand side of the room, plug it into the bottom.
Just say 0.
I don't know. What if it's not 0 over 0?
Well, then you get, if it's a number over 0, then it's not existing.
Okay, well, we need to know, don't we? Because if it's not 0 over 0, does L'Hopital's rule work? No. So left-hand side of the room, plug into the top, negative 2. It is negative 2. Left-hand side of the room, plug in negative 2 into the top. Right-hand side of the room, plug in negative 2 into the bottom. Use your brains, not your calculators. Yeah, but on half the AP exam, they take it away. Unfortunately. Top 0? Bottom?
0.
Okay, so what's that mean? Quick question. Do you want to factor this?
Nope.
Probably not. It's not impossible. It does factor by grouping. So it could have been done in AB calculus. You group the first two and you group the second two and you factor out a greatest common factor out of both groups. And then you look for a common binomial factor, like an x minus 2 in both pieces, and then you factor out the big binomial factor.
So does this rule work if it's going approaching left and right?
It will not give you the asymptote answers, but yes, I mean, if it's 0 over 0, it will work.
Okay.
So 3x squared minus, or plus 2x minus 8 over 3x squared plus 16x plus 20. Plug in negative 2. What do you get? 0 over 0.
So do it again.
So do it again. Or you could factor if you wanted to. 6x plus 2 over 6x plus 16. Plug in negative 2. And what do I get?
Well,
Negative 12 plus 2, so negative 10. Or negative 5 halves. Any questions about that one? You don't, but if it's multiple choice, you have to match it. So you should still practice it. Okay, let's look at the next one. Plugging in infinity. Do I get infinity over infinity?
it's a ratio, so
But it's still infinity over infinity, right?
right.
L'Hopital's rule will work, and I'm going to do it. But I hear several of you saying, but the answer, Miss King, is... So just because we have a new rule doesn't mean we always want to use it.
No.
Probably not. I will show you that it works. I'm going to do it, but you knew that answer was 4/3, right?
Couldn't you just do it with the first ones? So you get like 12.
The degrees are the same on top and bottom.
Yeah.
Those
Yeah, Larry said it's
plug, like if you actually plug in infinity,
oh, okay.
you get infinity over infinity, which means L'Hopital's rule will work. The limit is not infinity, but the top and bottom. 12x squared minus 7 over 9x squared plus 8x. And what would you have to do if you're really going to do L'Hopital's rule? Do it again, and you get infinity. You'd keep doing it, but eventually these would derivative out to be constants, a constant over a constant, right? And you would get the constant 4/3. I'm going to stop if y'all are okay with that.
So the limit and derivative are the same.
Trick, shortcut, has nothing to do with an actual derivative. We are not taking a quotient rule. We are not doing a real derivative. Okay. But L'Hopital's rule says that if you have a 0 over 0 or infinity over infinity limit, the limit as x approaches a of the function.
So it's making
Yes. We can make that limit easier sometimes by taking the derivative of the top and bottom.
Oh.
It's not a real derivative. It's short. It's not a derivative of the whole function. It's a derivative of the top and a derivative of the bottom. Okay, I'm going to work this with L'Hopital's rule, but then I'm going to also show you another way to work these two problems that is easier, even easier than L'Hopital's rule.
You're right.
Yes.
That's what I asked you.
So with L'Hopital's rule, do you get 0 over 0?
Yes.
If h is 0, e to the 4th minus e to the 4th over 0. So I can do L'Hopital's rule. The derivative e to the h plus, or the 4 plus h, is e to the 4 plus h times 1. But that's What's the derivative of e to the fourth?
E to the fourth, 4.
Nothing.
Why 0?
Constants.
E to the fourth is a number, right? It's a weird number, but it's a number. Plug 0 in for h, and I get e to the fourth. Everyone agree? That is the limit. 0 over 0 again, agreed? Derivative of sine of pi, or sine of x is cosine of x. What about the derivative of sine of pi over 4? Why is it 0?
It's a number.
Because sine of pi over 4 is just a number. Y'all listening? Sine of pi over 4 is just a number, so the derivative of it is 0.
Doesn't x equal a number?
No, x is a variable. I mean, it is a representation of being any variable, but it's not a number.
Oh my gosh. It doesn't equal.
Hey. Okay. The last two examples, however, are not really even limit questions. They are derivative questions. Why are they derivatives? What is the definition of a derivative?
That equation. H.
So look back at this. What is f?
E to the fourth.
E, right? Everyone agree e to the x is f of x? The x they've replaced with a 4. What is the derivative of e to the x? And what is the derivative at 4?
E to the 4.
See how this is just the definition of the derivative? Right? So is the bottom one. Let's see if I have more. Anyway, you have 2 worksheets. Number 60 is not on the L'Hopital's worksheet. It needs to be added. The 1 through 4, I think, is written at the top. Is 60 written at the top? I might have fixed it. Okay. So you have 2 worksheets to do. You notice L'Hopital's is pretty short, right? And then the inverse worksheet is what we learned yesterday. No, it's a book page. See at the top it says 1 through 4, page 454. Okay. I keep saying this, but I don't know if you're doing it or not. I haven't had any questions, so I kind of feel like probably haven't started yet. Remember, you need to start on that AP packet. The odds are going to be due on Wednesday next week. The evens are going to be due on Thursday next week. So start with the odds. They are going to be really hard for you at first because it's the first time you've ever seen AP open response. So get started, because even though it doesn't sound like a lot, 7 AP problems, not a big deal, right? It is a big deal. There's a reason I gave it to you early. So do 1 a night or something, starting now. Try number 1 with your homework tonight. You will have some time next week, but like I said, AP problems are no joke. They're tough. Have we talked about what you have to make on the AP exam to pass it in here yet?
No.
Let me show you.